All right, let's learn about hash maps in Rust. All right, so Rust's, what happened? Okay, so Rust's standard collection library, like Rust has its library as we've seen, has implementations of some of the most common data structures. We've even worked with vectors previously. If you remember, vectors is a struct and we bring it in and it uses contiguous memory, right? Similar to an array, but it's resizable. Anyway, okay, so I want to look at another very common data structure, the hash map, which you find in many languages. So the hash map, basically you have to think of it as this table of key value pairs. It stores the mapping, we say key for the keys and v for the value. So it does this with a hashing function, which determines how it places these keys and values into memory. It'll be fairly arbitrary. Many different programming languages support this kind of data structure, but they'll use different names, hash, mapping, hash table, blah-de-blah, blah, okay? Hash maps are useful for when you want to look up data not by an index, as we would with vectors, but let's say we want to be using a key that can be of any type. So in a game, you can keep track of each team's score in a hash map. Key can be the team's names, and then values can be their score, right? Key value pairs, very powerful data structuring. Important to note before we dive in, there's no two entries in a map that can have the same key. So because of that, think about these maps like a lookup table where you're looking at the keys and you're like, all right, do we have all these keys in the table? Okay, what are the values for them? Do we want to look up a specific one? Do we want to remove one? Do we want to add? Things like that. And here's actually different types of methods that are associated. And of course, we're using the and self, right? Because these are methods, part of the structure. And these are things that we've been learning about. So hopefully it's coming together in your mind. So we have insert, we have len, we've seen for length, we've got get. You can iterate through, you can check whether something contains, if it's true or false, and you can remove. I'm not going to go so deep in everything all the time, but hopefully you get the idea. Let's actually take a look at some examples, and that should bring this interesting soup together for a delicious supper of Rust. So we're going to do a hash map example, and notice notice how we have this camel case format where the second word is uppercase. All right. Now, since this is coming from the standard collections and we want to use it, we're going to use the use keyword. We're going to do std for standard, and we bring in collections, and within our collections we get our hash map. And I only need one space between. And ipso facto, we've got our hash map. So now that we've imported from our standard collection library in Rust, shall we? So we're going to do function main. Function main. Done. Dunsky. So let's say we want to have account information, which has names and their account status. So let's make a table for that, and we have a couple names. How would we do that? Well, we can have a variable. It's going to be mutable, and it could be account, and then here, camel case for the second, and then their uppercase for the second word, equals, and we want a hash map. So we're going to make a hash map, and to get a new instance, we bring in new. And now we're basically setting up a table for account info as a hash map. So now we can do things. Now we should be able to access an account info these methods. So let's insert some names and account standing. So I could say account info.insert, and now I could add keys and values. So we could have a key of Johnny with a value of, let's say, overdraft. Johnny, you got to pay more attention. Johnny. All right, we're going to do this 3 times. We're going to add different things. So we got Sally. Sally's account is in good standing. Good job, Sally. And then we could have Superman. And Superman has insufficient funds. Okay. Even Superman can come across financially difficult moments. And so technically here we should have added 3 things, right? There should be 3 key value pairs in our hash map. So why don't we actually see if that's true, so you don't have to take my word for it. So why don't we print the length? So we could say the size of the map is, we can bring in the account info.length, And let's go ahead and run this code. Let's see if it works. So, running the code. And we see here at the bottom the size of the map is 3. The size of the map is 3, and that definitely makes sense to me mathematically, because mathematically speaking, we added 3 key value pairs, and they counted 1, 2, and 3. You know, if I were to comment one out and run it again, we should see 2, right? So let's see what happens. Scroll down. Oops, I can't see. The size of the map is 2. Beautiful. Okay, and there you go. So effectively together, brought in from the standard collection library, HashMap, and now in Rust, what we're doing is we're creating a nice table of key paired values. Very good. Let's go ahead and stop our lesson here. I think it's a good stopping point. And I'm going to test you in the next lesson, and I can test you with some of these other methods. See if you can figure out how to solve an exercise on your own. Okay, I'll see you there.